Okay, today is Module 1, Lesson 25, Fractions as a percent. So we're going to continue, just like on Friday, to look at the relationship between decimals, fractions, and percent, and how there are three different ways to represent the same value. Okay? So let's take a look at example 1. Create two ratios that would describe the images. By the way, this image here, the trucks, that's a truck with a trailer. It's not like a separate bus or a separate trailer. It's not my clip art. Okay? So somebody give me a ratio for this picture. Tell me what it is and the ratio.
3 out of
So
3 out of
3,
7.
well, there's 3 what?
Cars.
So we have 3 cars, and how many trucks do we have?
2.
2 trucks. So cars to trucks is 3 to 2. Okay?
I thought you said it would be added with trailers.
No, the trailers are part of the truck.
Oh.
Yeah, that's part of it. They go together.
Trucks to trailers should be 2.
We're counting this as one image. That's 1 truck, that's 2 trucks. Okay? Just pretend those trailers aren't even there.
So we could do 3 to 5.
Where did you get 3 to 5? What is the 5? What's the 3?
The little green cars are the 3, and the 5 is the whole.
All right, so the total vehicles. So cars to vehicles is 3 to 5. Somebody come up with something else?
We could do trucks to vehicles, just 3 to 5.
Trucks to vehicles, which is 2 to 5. And give me one more. What would give me another one?
Trucks to cars.
Would be
2 to 3.
2 to 3. How could I describe those two ratios versus these two ratios? What type of ratios are this? What kind of ratios can we say these are? Excuse me? They are. They are. That's true. Yeah, these are part to part. So now what are these? Very good. Any questions on why it's part to part or part to whole, or where did the 5 come from? Where did the 3 come from? Where did the 2 come from? Any questions? All right, let's take a look at the next one. Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. Okay? So first, let's take a look at that fraction. Look at it as a fraction. I'm putting my pen in my pocket. Okay. So 50%. Let's look at it as a fraction. We're looking at vehicles to cars. What is our ratio of vehicles to cars? Or cars to vehicles. What's our ratio of cars to vehicles? 3 to 5. What's another way to write a ratio? What's another way we could write a ratio?
3 over 5.
Yeah, we could write that as a fraction. Part to whole. What's another way that we learned on Friday that would represent the same value? Instead of a fraction, we could write it as a percent. What is our whole when we're looking at a percent? What's our total when we're looking at the percent? What does percent mean? Percent means out of 100. So what's our whole? 100. fraction or other ratio would be equivalent to 3/5 that would have 100 as the whole? How'd you do that? How'd you get 60? All right, so you did, why did you multiply them by 20? Okay, we had to use a constant. 5 times 20 is 100. 3 times 20 is 60. So 60 over 100 can be written as 60%. So what percent of the vehicles are cars? What percent of the vehicles are cars? 60%. Sam said it was 50. Is she correct? No. So those don't equal. So she's wrong. Or he is wrong. I don't know if Sam is a boy or a girl. Doesn't matter. Alright, so that's one way. Ratio to a fraction to a percent. So her percentage was wrong. Let's try drawing a model. So what is our whole? If we're going to do like a double number line, what's our whole? How many vehicles are there? 5. How many of those 5, I'll use green because they're green cars. 1, 2, 3. So 3 of the 5 are cars. And then if we wanted to label these as trucks, we can. What did we say our whole had to be? What is our whole? 100 what? Percent. So now I have to take my 100% and go from 0 to 100 in how many steps? 1, 2, 3, 4, 5. Take that 100, break it into 5 pieces. So how am I going to label? What's 100 divided into 5 even sections? What's it going to be? Right. So this is 20%, 40%, 60%, 80%. So what percent are cars? What percent are cars? 60%. Questions? Where did the 60 come from? Where did the 40 come from? Why did you put the 80 there? Why did we shade in 3 boxes? Those are some good questions to ask. Anybody have a question?
How did you end up deciding how to go by it?
Because there were 5 sections, there were 5 vehicles. So far so good? My whole equals 100%. So I have to take 100% and divide it evenly into 5 sections. So 100 divided by 5 is 20. So I knew I had to count by 20. So remember, we want even intervals. 20, 40, 60, 80, 100. Good question. Did I answer it okay, or do I need to answer it a different way?
No, that makes sense.
Okay, good. Now check this one out. You don't have to draw it. I just want to look at it and discuss it. How would we use a hundreds grid to represent 3/5 equaling 80%. So here we have a 100 grid. It's a 10 by 10 100 grid. What do these big black lines through the middle mean? I'm going to go over them with my highlighter. What do these big black lines? They divided the 100 grid into how many sections? Everybody? 5 sections. Divided it into fifths because there are 5 vehicles. How many, by the way, are in each section now that we've divided it up? How many are in each section? 20. So they shaded in 3 of the 5 sections because there are 3 cars. So how many boxes are shaded in blue to represent the 3 cars? They shaded in 3 of the 5 sections. So how many? 60. So this shows 60%. So all 3 methods show that 60% were cars, not 50. Any questions? All right, let's keep going. Take a look at example 2. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part-to-whole ratio for comparing happy participants to the whole. Then write a part-to-whole ratio of the unhappy participants to the whole. What percent were happy and what percent were unhappy? So let's go back and highlight the important information because there's a lot of words here. So 300 of the participants were unhappy, 700 of the participants were happy. Much easier now. So the first thing we have to do is write a part-to-whole ratio of unhappy and happy. So we'll do happy first. What is my ratio first? What is my ratio of happy?
I would do 7 to 10.
I don't see a 7 or a 10 here.
7.
So back it up a little bit.
700 to 1,000.
Right, so we have 700 to 1,000. Who wants to know where the 1,000 came from? Who's not sure where the 1,000 came from? We're looking at part 2 whole. So 700 people were happy out of a total of 1,000 people. So 700 plus 300 tells us there were a total of 1,000 people that were interviewed. Are we okay with where the 1,000 came from? What's another way that we can write our ratio?
7 to 10.
Well, first we could write it as a fraction, 700 to 1,000. But does percent mean out of 1,000? No, what does percent mean? Percent means out of 100. So we do want to reduce it, but we don't want to reduce it to 7 over 10. If it means out of 100, what do we want to reduce that to? We want to reduce it to out of 100. Right, 70 over 100. Now it's easier to find the percent. What's the percent? Right. Try to do the unhappy on your own. So unhappy, what's my ratio first?
300 to 1,000.
Whoops. That could be written as 300 over 1,000, which reduces to 30 over 100. We want it over 100, So then it's easier to write as a percent. Okay, please write everything on your notes that I write on the board. So if I write it as a ratio, then as a fraction, you should be writing everything down. Okay? Now let's try a model. So draw your double number line or tape diagrams or child of both. So draw, oops. Come on. Draw the model. 10 boxes. We always start at 0. Our double number line. So across the top, if we're going to put number of people across the top, what's our total number of people that were surveyed? What's our total number of people? Total number of people that we surveyed? 1,000. What's our whole percent? If 1,000 of the 1,000 answered, how many answered? The full 100%. Now we have to figure out how to number our number line all the way down. So how do I get from 0 to 100% in 10 jumps? Sure. So 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, 100%. Now how are we going to label the people? I have to get to 1,000. So how am I going to label the top to get to 1,000? Sure, let's go by hundreds. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. This is actually easier because now I can find both my answers at the same time. 300 people is 30%. 700 people is 70%. Now I know a lot of you can do this mentally. Mental math, you can figure it out. However, will we always be working with tens and hundreds? No. So it's important that we practice these methods because they will help us when we're working with other numbers that aren't as kind and friendly, that make us mental, that make us go mental. All right. Okay. So let's continue. Everybody ready? You okay? You okay? All right, let's take a look at this picture. Renita claims that a score of 80% is the same as the fraction 4/5. She drew the following picture in order to support her claim. So we're trying to prove, if you want to write it over here, 80% equals 4/5. That's the question. That's what we're trying to find out. Does 80% equal 4/5? When we did this last period, we did all the work and then we forgot what the question was. Now the model that they chose to use was a 100 grid, but is that a 100 grid? It doesn't look like a 10 by 10 100 grid. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 times 1, 2, 3, 4, 5. So 20 by 5, it's a 100 grid. I wonder why they did 20 by 5 to make 5 rows. Why why did they do 5 rows and then only shade in 4 of the 5 rows? Why didn't they just do 100 by 10 by 10? Why did they do 20 by 5? It does, but back it up a step. Make it simpler. Because it's what? Because it's what, Lauren? Yeah, 4 out of 5. 4/5 means 4 out of 5. So she shaded 4 out of 5. And we were able to see that our constant was what? How many are in each row? 20. So 20 times 4 is 80. So if we wanted to number this side, this would be 20%, 40%, 60, 80, 100%. We're looking at the 80%. So is she correct? Is 4/5, 4 out of 5 equal to 80%? Yes. She is correct. And if we want to show this as fractions, 4/5 equals 40 out of 50, which equals 80 over 100. We always want it out of 100 because what means out of 100%? So when it's over 100, it's easier to see it as a percent. So is she correct? Yes. Any questions? Oops. Quick, don't look. All right. All right, turn the page. They already drew the double number line for you. How nice of them. So what is our whole? What fractions are we looking at here for the 100%? What fractions are we looking at? Fifths. So I have 1/5, 2/5, 3/5, 4/5, and 5/5. So 80, the number 80 is what fraction, I guess it should be 80%, is what fraction of the whole quantity? So point to your 80%. What fraction would it be? Right. Is anybody not sure where the 4 came from, where the 5 came from? Any questions on that? All right, 1/5 is what percent of the whole quantity? 1 out of 5, 1. What percent is that, everybody?
20%.
50% is what fraction of the whole quantity? What? There's no 50 on my double number line. Ah! There's no 50 there. What am I going to do? So 50 is right between nice and even. So if I cut that in half, what's halfway between 2 and 3? 2.5. So it's 2.5 over 5? Really? Is that okay?
No.
Yes, that is. If you don't like it, we could do it like this. 2.5 over 5. But if the decimal is really freaking you out, since it was 50%, if it's really freaking you out, how could we rewrite it so there's no decimal in the numerator? How could I rewrite that so that there's no decimal in the numerator? I have to leave it as a fraction because it's asking you for a fraction. No, that's only if the numerator is bigger than the denominator. Okay? How can I change that so it isn't a decimal?
Maybe multiply 2 by 2 plus 1.
I could multiply them both and find an equivalent fraction. So if I multiply them both by 10, 25 over 50. Yours would have worked. Instead of multiplying by 10, you could have multiplied them both by 2 and gotten 5/10. 5/10 would have worked also. I like 10. Move the decimal over. Yes. Yeah. Yep. 1 is what percent of the whole quantity? Be careful. It's not 1/5. Everybody write down your answer. I want to see what you write down for the last one. They're looking for a percent. The answer has to be a percent. Be careful what they're asking you for. Just a percent, not a fraction. And it's not 1/5. It's 1 whole. It's not 1/5. 1 is the same thing as 5/5. So what's my 1 whole? My 5/5 equals what? 100%. Let's go back and quickly write each one as a decimal now. Okay, so we're going to go back and write each one as a decimal. So what is 4/5 as a decimal? 0.80 or 0.8. Let's write this down, please. What is 20% as a decimal? 0.20. Huh. What's that next one as a decimal? It might be easier if we made that out of 100. Now what is that as a decimal? What would that be as a decimal? Yeah. And what's our last one as a decimal? Come on, let's add these as decimals.
Just 1.
1 whole. If you want to put the decimal there because it says as a decimal, make sure that you know the decimal goes after the whole number. So it'll be 1 whole. Now your homework tonight is the problem set lesson 25, which is on page 115. Number 1 you can do right on the paper because you need that 100 grid. But 2 through 5 should be on loose sleeve. Okay?